There are two triangles that we use a lot. We call them special right triangles. One of our special right triangles is a 30, 60, 90 triangle, and the other one is a 45, 45, 90 triangle. On our 30, 60, 90 triangle, we have this relationship that happens with the sides, which makes it so it's relatively quick to find the other side lengths without having to do trigonometry, so your sine, cosine, or tangent. So this value is double the side across from 30, so your hypotenuse is double across from 30. And then to go from the leg of across from 30 to across from 60, you times it by root 3. Now, on our 45, 45, 90, it also has a special relationship. So remember that there was a theorem in geometry that said if you have congruent angles that the sides opposite them are congruent. So we already know that these two angles will be the same. So whatever those are, those match. Then you can do the Pythagorean to find the third side, but it always ends up being x square root of 2. So really you should have these memorized. Sometimes I prefer to memorize them with just numbers and look at the relationship with the sides as opposed to having x values. So 1, 1, root 2, or with your 30, 60, 90 triangle. Across from the 30 is the 1, the hypotenuse is 2, and then the leftover side is root 3, or across from the 60 is the root 3. Right? So we can use these to have our values of our 30, 60, 90 triangles. Right? So for example, if we were to take a look at this triangle here, and I gave you that this side was 20. Well, we can think of this of one of two ways. I can think, well, this is really 2x, this is x, and this is x root 3. So if I want to find out what 2x is, I can set 2x equal to 20, and then we can solve. Well, this is being multiplied, so to undo multiplying, we divide, so then x is 10. Okay? Which means that that's 10, and then we're going to have this as x root 3, so this will be 10 root 3. That's one way that you can think about it. A second way that you can think about it is how to go from one to the next. So this side length is 2, this is 1, this is root 3. So how do I go from here to here? Well, I divide by 2. So to go from 20 to this side, I'm going to take 20 and divide by 2, and that will give me the side where 1 is. So that gives us that this side length is 10. To go from 1 to root 3, I'm thinking, well, I multiply by root 3. So if I take the 10 and I multiply by root 3, I get 10 root 3. So those are kind of my two different ways of looking at the problem. Okay? Now you can orient the triangle a whole bunch of different ways, but they will still be the same thing. So I always like to remember across from the 30 is the 1, the hypotenuse is 2, and across from the 60 is the root 3. You technically really only need to remember 2 of those 3 because you can always do the Pythagorean theorem to find the third side. If I were to give you this triangle here, I tell you this is 45 and 45. If I tell you this is 7, that's not what I was trying to do, 7, and we wanted to find these two sides. This doesn't look good. Let's try again. This is 7, and I want to find the other two sides. Well, first of all, we know these two sides match, or they're the same value. Again, you can go about the same way that this is x, x, x root 2. So if you know 7 is x, then this other side across from the other 45 has to be x as well. So that means that this side has to be 7 root 2. Or you can do where I say this is 1, 1, root 2, and I'm saying, well, how do I go from 1 to root 2? Well, I multiply by root 2. So then that side would be 7 root 2. So let's try a couple of other examples. So you can get where they're more complicated. Let's try a few of the easier examples first, and then we'll go to some more complicated ones. So if I give you this triangle here, and I tell you that this is 8 root 3. Okay, well, first I kind of want to orient myself. So this side is the root 3, this side is the 1, this is the 2. Okay. So I'm thinking, well, to go from root 3 to 1, I need to divide by root 3. So if I take 8 root 3 and I divide by root 3, that just gives us 8. So then this side length has to be 8. If I want to know, well, how do I go from here to here? Well, I need to multiply by 2. So if I take 8 and I multiply by 2, then that gives us 16. Right? It's not so bad when we do that. If I give you this triangle here, and I tell you that this is 9, right? If we label our triangle, last time I did with the 1, 2, 3, word 3, so this time I'll do x, 2x, and x root 3. So here, we already know that 9 is x. So that means if I want x root 3, that means that that's going to be 9 root 3. If I want 2 times x, that's going to be 2 times 9, which gives us 18. Still not so bad. It's when we get to slightly more complicated ones, like if I were to give you this triangle. What if I were to give you 5? So if we label our triangle, this side is x root 3, this side is 2x, this side is x. Well, here we have 5 is x root 3. Well, I'm trying to figure out what x is, so what I want to do is I want to undo timesing by root 3. So to get rid of timesing by root 3, we divide by root 3. Well, to divide by root 3, don't forget that we rationalize. So that means that I'm going to times by root 3 on top and bottom. So that means that our x is really 5 root 3 over 3. So we now know this is 5 root 3 over 3. Well, I need to find the 2x side. So to find the 2x side, we're taking 5 root 3 over 3 and we're timesing it by 2. Remember that 2 is really 2 over 1. And to multiply fractions, you multiply straight across. So this will be 10 root 3, because we do 5 times 2, over 3 times 1, which is 3. So then this side is 10 root 3 over 3. Now the other way you could look at this, root 3, 1, 2. To go from root 3 to 1, we have to divide by root 3. So I would take 5 and I would divide it by 3, which I know I need to rationalize. So I times by root 3 on top and bottom, so we get 5 root 3 over 3. Which notice is the same thing we got here. So there's kind of 2 different ways to look at it. Both of them get you to the same spot, but it's fine. So let's try. Oh, that's not what I was trying to do. I was seeing what the stickies would do. I thought I would put a new blank one. I guess not. So now we will just erase. Oh, you can move the sticky. Delete. You get to see me trying my new technology. I need to figure out a faster way to do this. Oh well, for right now. So if we try a trickier one on the 45, 45, 90, that was a horribly drawn triangle. This is, let's call this 12. So that side is normally the side that is root 2. Right? So this is either x root 2, or you're thinking this is root 2, this is 1, 1. So if you go this way, you're thinking, well, here I need to divide by root 2. So I would take 12 and I would divide by root 2, which again, we need to rationalize. So I times by root 2 on top and bottom. So we end up with 12 root 2 over 2, which notice this part right here can be reduced because 12 halves can go to 6. So then that will leave me with 6 root 2. But I could have also looked at it and said, well, x root 2 is 12, so I want to undo timesing by root 2, so I'm going to divide by root 2. So then we get x is 12 root 2 over 2, and then that can reduce, so you get 6 root 2. So you get to the same spot on both of them. You just are different ways of looking at them. Right? Now, what if I give you a problem where you have a root, but it's not the root that it's supposed to be? So what if I give you, like on a 30, 60, 90 triangle, let's not do that color. This is your 60, that's your 30. If I give you on your 30, 60, 90 triangle that this is 5 root 7. Okay. Well, that, if you remember, is really supposed to be x root 3. So if I set x root 3 equal to 5 root 7, well, I need to undo timesing by this root 3. So I'm going to divide by root 3. Well, if I divide by root 3 on the right side, that means I really need to rationalize. So I'm going to times by root 3 on top and bottom. So we end up with 5 root 7 times 3 over 3. Notice 7 and 3 are primes, so I can't do anything and pull anything out, so I get 5 root 21 over 3. So then that becomes this value here, so 5 root 21 over 3, because this is our x value. Well, to get to the hypotenuse, we need to do 2 times that amount. So if I do 2 times 5 root 21 over 3, remember that fractions, you do top times top over bottom times top bottom. So when I multiply here, I get 10 root 21 over 3. I look to see if I can reduce on this part here, 10/3 I cannot. So then that leaves me with my answer that this is 10 root 21 over 3. Let's try when you have a different one on, or a more complicated one on your 45, 45, 90 triangle. So remember on your 45, 45, 90 triangle, it's 1, 1 root 2. Okay. So if I have, let's give you this as, nope, I don't want yellow, sorry. Let's go 5 root 6. So again, on our triangle, this is supposed to be x root 2, this is supposed to be x and x. Or you can think 1, 1 root 2. If you're thinking 1, 1 root 2, you're thinking to go from root 2 to 1, I have to divide by root 2. So, or you have x root 2 equals 5 root 6. So here, I want to undo timesing by root 2, so we undo timesing by dividing. I guess I would like writing slanted. Sorry. So here we get x equals, I need to rationalize, so I'm going to times by root 2 on top and bottom, so I get 5 root 6 times 2 over 2. But notice I can break down 6, so 6 is really 3 times 2, but now I have a pair of 2's. So then this can simplify to 5 times 2 root 3 over 2, but then notice again, this can simplify to 1, so when I cancel the 2's, then I just end up with 5 root 3. So these are 5 root 3 and 5 root 3. So those are your special right triangles that you can have that make it so that it's quicker to find the sides. And you're finding the exact value of the side instead of when you use sine, cosine, or tangent, you would find an approximation.